Precipitation reactions. We've done precipitation reactions in lab already. Now we're going to learn what's going on. Okay, precipitation reaction is a reaction in which we get a precipitate. That's what chemists call it, a precipitate. Doesn't this look a little bit like a big cloud of snow or something? In meteorology, a precipitation, is what? It's like rain or snow or sleet or hail. It's something falling from the sky, right? So in chemistry, a precipitate is something that falls out of solution. And as we saw with our barium sulfate, it may be all cloudy at first, but if we let it sit, it will settle, and all that solid stuff will go down to the bottom. So a precipitation reaction, what happens, like in this example here, we've got potassium iodide and lead nitrate. They are both soluble compounds, right? All potassium compounds are soluble, all nitrate compounds are soluble. So they make these nice clear solutions. We pour them together and we get a yellow solid forming, and it looks like magic. Chemists like to do magic shows because people who don't know very much chemistry are easily impressed by them. It can be, really exciting. Well, what's going on here? Well, we've got now 4 ions mixing together. We've got lead, nitrate, iodide, and potassium. One of those combinations forms an insoluble compound. Iodides are generally soluble except with silver, mercury 1, and lead 2. Here we're bringing in lead 2 ion, or we're bringing in iodide, I forget which, we're bringing in iodide, mixing it with the lead 2. Those guys really, really like each other. They are going to get together and fall to the bottom and not be soluble. So here's a different way of looking at it. So in the potassium iodide, we've got 2 kinds of ions. In the lead nitrate, we've got 2 kinds of ions. And so we have a possibility of these switching partners. I like to think of this in terms of couples. I've told you before, I think of the metals as masculine and the nonmetals as feminine. So the cations are the men and the anions are the women. So here you've got potassium, a guy coming in with iodide, a girl. And they like each other okay. They came to the party. This is the party over here. So they came in the car to the party. And here we've got lead and nitrate. Yeah, we're okay. We were riding in the same car. You mix them together, and lead sees iodide, and his eyes bug out of his head, and they just go, and they're gone. Hey, have you seen lead? Oh, I think I saw him run off with iodide. They're in the back room or something, sitting on the back porch talking, hopefully. But they're just going to be together, right? Lead and iodide are insoluble. Yeah, it's weird, but you'll remember. So here they are at the bottom of the beaker. Everybody else is mingling and having a great time, and they're down here. So when we look at predicting a precipitation reaction, we're going to look at what are the possible new combinations that we could have. And we've got a positive and a negative coming in, a positive and a negative coming in. There's really only one possibility. We can swap the partners. Now we've got 2 new couples, and then we have to examine them in terms of the solubility rules. If they are insoluble, they will form a precipitate. If they are soluble, they will not. They'll just continue mingling. So precipitation reactions do not always occur when 2 aqueous solutions are mixed, only if the new combination of ions forms an insoluble compound. So here's an example, potassium iodide, sodium chloride. Well, what are the new possibilities? Potassium came in with iodide. He could leave with the other one, right? Chloride. So one way we can do this is we can look at the individual ions. There's sodium, and there's chloride. And then we could say, well, what if we swap partners? Is there any chemistry happening? Well, we've got potassium then with chloride. That's a possibility. And we've got sodium with iodide. How do we tell if they're going to hit it off? You look at the solubility tables, the solubility rules. Well, all potassium compounds are soluble. Chloride, this isn't one of the exceptions. So this one's soluble. They're just going to keep mingling. They're not going to precipitate. All sodium compounds are soluble. Most iodide compounds are soluble. This is not an exception. They are also going to mingle. So we say there's no reaction. Nothing happened. Just things mixing. That's not a chemical change. It's just mixing. It's a physical change, but not a chemical change. So we need to be able to predict the products of precipitation reactions and write balanced chemical equations for them. So for those of you who like lists, here's your list. You need the formulas for both of the reactants. Below that, just like I did on the previous slide, write the formulas for, I didn't edit this as much as I should have. Okay, back up. Write the formulas for the products, the reactants. Write the formulas for the possible products. Look at the solubility rules to see if anybody's going to hit it off, if anybody's insoluble. If all of the possible products are soluble, then you can write no reaction, or we even allow an abbreviation of that, capital N period, capital R period, no reaction. Everybody likes those because they're fast. There's nothing to balance. Like, yay, we're done. If any of those products are insoluble, then you have to write the formulas for all the products and balance the equation. Precipitation equations, I should say, are equations where we do care about these state symbols. We want to indicate which of those products is the solid and which one remains aqueous. So let's do an example. Okay. So potassium fluoride, here they're being mean, they're giving us names to start with. To write the formula for an ionic compound, you need the ion formulas first. Potassium is what? K, and the charge is plus. And fluoride is F with a -1. And the other one, we've got strontium is Sr. Can we tell what the charge is? Where is it in the periodic table? Group 2 is 2+. And nitrate is NO3-. Okay, so those are the ions that make up our reactants. So we need to make those into compounds. So we've got Kf +1 -1, and we've got Sr, and we need 2 nitrates to balance the charge on that strontium. They are telling us that these are aqueous. We should write those down. Aqueous. Plus, I'm going to leave a space there in case I need to balance this. Here's my arrow. There we've got the reactants. Now, to do the products, I really, really encourage you to write these out with their charges. We've got to jump on figuring out what the possible products are, because we've already got the ions written down here. We're just going to switch partners, the strontium with the fluoride, the potassium with the nitrate. Okay. This party that's happening in the beaker, very, very traditional party, okay? Like in the middle of Iowa. This is not happening in San Francisco, okay? We can't have a cation and a cation getting together. We can't have the 2 guys and 2 girls. Now, in real life, that happens. We're not going to talk about that. But it does not happen in the beaker, okay? Because this is about electrical charges. Positive is attracted to negative. 2 cations will repel each other. You can't force them together. Students try to do that, and you can write it that way on the paper, but it's going to be wrong. It has to be positive, negative, positive, negative. Okay? So there's only one possible way to rearrange these. So I'm just going to write them over here. We could have K plus with NO3 minus, and we can have SR2 plus with fluoride. Now we have to go to the solubility rules and see, is either of these insoluble? What about potassium and nitrate? This is soluble. Potassium compound's always soluble, nitrate compound's always soluble. What about these two? Fluoride is a halide ion. Those are generally soluble, right? There were some exceptions. Do you remember what they are? Silver 1, mercury 1, and lead 2. This isn't one of those. So this must be soluble, right? What do we do? No reaction. There is no chemical reaction here. It's just a physical mixing of things. Let's do the other one. Ammonium. What's the formula? NH4 plus. Perchlorate. Okay, what's chlorate? Chlorate, ClO3. So per is more, ClO4, the -1 charge. Sodium, group 1, so very fat A. Bromide, another one of those halides, minus. So we put these together. Here we got +1, -1. We can just shove them together and say, hey, look, there you are. And that's aqueous. And then sodium and bromide are also +1, -1. Sodium, bromide, and that's aqueous. And we do that partner swap and see what we come up with. NH4 plus now with bromide and sodium with perchlorate. What do you think?
No reaction.
No reaction. Like on an exam, if you had those two questions and there weren't any others, you might think, couldn't possibly both be no reaction, right? And as a teacher, I'm looking at that. Did I really put 2 no reactions on the slide? I didn't even do 1. It is what it is. Yeah, new section.